All right, I will be talking about the greenhouse gas GC today, which is model 7890B from Agilent. This is a nice picture we have of the instrument there, and you can see it's got a Gerstel MPS auto sampler system on top there. This instrument was actually custom designed by a guy named Kevin Comark at Michigan State University. He works in the Kellogg LTER project, so they do actually some cross project work with the CAT people here. I actually went to Michigan and trained with Kevin on their two instruments to get a better sense of how it all works, because it's kind of a unique setup. But let's do basics first. So what is a GC? GC stands for gas chromatograph. So gas chromatography is basically a technique that utilizes a mobile phase, which is generally an inert gas, and a stationary phase, like the coated walls of a column, to separate out constituents based on their affinities. And then they come out at different times, and that's measured on different detectors. We call that retention times. Things are displayed as peaks. So you can see the nice little pictogram I have down there. So this instrument is specifically set up to measure the three major greenhouse gases: methane, carbon dioxide, and nitrous oxide. To do that, we have three completely separate detectors, as well as three columns in the oven and four gases that feed into the instrument. So to measure methane, we have a flame ionization detector. I'll go into the FID and the ECD a little bit more on the next page, but just briefly, an FID is pyrolyzing hydrocarbons with a hydrogen flame, and then generating a current from those ions and detecting the changes in current. We have air that flows through that to help keep that flame lit. The carbon dioxide is measured via a Lycor 820 NDIR detector. This is the exact same detector setup that's on the Shimadzu TalkV to measure carbon dioxide. So I've already gone into that a little bit, so I won't go into that as much in this presentation, but if we need a refresher, we can always do that. But basically that's spectroscopic. So it's using an infrared beam across the sample cell, and it just measures the amount that's absorbed by the carbon dioxide passing through. And nitrogen is our carrier gas in that case. And then our last detector is called an electron capture device. And that is using radioactive beta electron particles with nickel-63 as its source. And this is for electronegative molecules. I'll go into that more. And then the carrier gas for this is a P10, which is 5% methane in argon. And then I just included our current calibration range for each analyte down in the middle there, so you can just see kind of what the current range of the instrument is. Okay, so on the left there is a picture of our FID. You can see there's two electrodes. They provide this potential difference. The positive one is down near where the flame is being produced, and the negative one is above that, and we call that the collector plate. So the ions are attracted towards the collector plate, and that induces a current. And then we have a picoammeter, which measures that current, feeds it into an integrator, and then that's just displayed with time on the x-axis and total ion count on the y-axis, giving you nice peaks. And then the ECD, you can see that yellow outline there. That's the radioactive foil, which is emitting beta particles. So basically, the response of this is based on molecules' ability to capture these electrons. And the detector chamber contains 2 electrodes as well. And the ions formed are collected and create this steady standing current. So then when molecules enter and absorb these ions, then that changes the current. And it actually reads negatively, but then flips it around, and what you see on the detector becomes a positive peak. So here's some more pictures just so you can see that box in the back as the LICOR detector. That's actually a pretty cool company. They sell these detectors as field kits. Like, you can take that whole box into the field and connect it to a laptop, and it will read carbon dioxide readings wherever you happen to be, but we just have it set up to our instrument right now. So it has this manual injection port over there with the other arrow. It's set up to run with the auto sampler and everything, but if we wanted to, we could take it off and take it into the field. And then down on the right is the oven. That's like a picture of the inside of the oven, and you can see the 3 packed columns in there. They're actually all the same type of column, these Poropack Q, which is just a porous polymer. You can see it's comprised of ethylvinabenzene and divinabenzene, which is good for hydrocarbons, things in water, oxides of nitrogen, all the things that we want to measure. So we actually have the column in the front, which is strictly dedicated to the FID front detector for methane. And then the back 2 are actually both for the ECD. And one is running sample while the other one is venting. So that's like a constant back and forth that's happening on the back detector side. Okay, and then we have these cute little 6 ml vials, which we use on our sample racks. These racks are actually custom designed and fabricated with the help of Samrat. He helped me custom create those, which is pretty cool. And these vials have to be overpressurized to get good readings on the instrument. So we have them overpressurized by 8 mils, always flushed with nitrogen first to make sure there's no remaining gases in there. And then we're currently having customers either borrow vials and take samples in the field in the vials, or they can also transfer into our vials if they don't like that setup. So it's also good to talk about, you know, potentially what else we could measure on this instrument if people were so interested. Sulfur hexafluoride is another greenhouse gas of interest that actually has been measured on this instrument, not on our current instrument, but like on the one in Michigan. They've done successful tests with that. So that could be a viable option. Other types of hydrocarbons, different electronegative things via the ECD, and then if we wanted to do carbon monoxide via the LICOR, we could do that as well. And I have my little disclaimer down there about how that would require changes to the various setup and method development, yada yada. And then popular applications of this, environmental gas monitoring, soil flux, catalysis, closed chamber respiration studies. I actually included a little picture there of a soil flux closed chamber respiration study in a field, and that's actually, that little box is kind of similar setup to what the LICOR would be doing in the field, just connected to that little closed chamber.